special case of w equal to z the power n, that is for n equal to 2, and that becomes w equal to z square. So we're going to study this. So w equal to z the power n being the positive integer, and we have taken the special case where n is equal to 2. That is w equal to z square, right? So now let's take the derivative of w with respect to z to check whether the conformal property holds or not at z equal to 0, right? So what is the derivative of w with respect to z? It is 2z, right? And this derivative at z equal to 0 becomes, because the derivative of w at z equal to 0 is 0, that means the conformal property does not hold at z equal to 0, right? So hence the conformal mapping does not hold good at the origin. Now w equal to z square. For this we are taking z equal to x plus iota y and w equal to u plus iota v. So let's write this. U plus iota v is equal to x plus iota y whole square. Opening the bracket, we get x square minus y square plus twice of iota xy, right? On comparing the real and imaginary parts, we get u equal to x square minus y square and v is equal to 2xy. Now according to this, let's find out the images in the w plane, right, for the conditions in the z plane. So for the case 1, so if this is your z plane and this is your w plane, this is your x and this is your y axis, and this is your u and this is the v axis. For x equal to a, we are getting the line parallel to the y axis. So this is x equal to a. What image we get here, right? Let's see that. We are having the condition that u equal to x square minus y square and v equal to 2xy. So let's put the value of x equal to a in these. U equal to x square minus y square. For x equal to a, we are getting u equal to a square minus y square, right? And v is equal to 2xy. For x equal to a, we are getting v equal to 2ay. Marking this equation as 1 and this equation as 2, we need to eliminate y from these two equations. So eliminating y, we get from 1 and 2, you just put y equal to v divided by 2a in this first equation and getting the equation as v square equal to negative of 4a square into u minus a square, right? So what this equation represent? This equation represents a parabola, right? In the negative direction, because we are having here the negative sign. So in the negative direction, in the negative u-axis, so this is the equation of parabola with vertex equal to, here we are having u minus a square. So the vertex becomes a square comma 0. So let's write this. The equation v square equal to negative 4a square into u minus a square. This represents a parabola with vertex a square 0, focus at the origin and having u axis in the negative direction as axis of parabola. So in the w plane we are getting a parabola, right? This is your point a square 0 as the vertex, and this is the parabola v square equal to negative 4a square into u minus a square, right? Okay, now let's move on to the case 2. Where we are taking x to be equal to b. So if I take x equal to b, that is the line parallel to the y-axis, And for this, let's check what image we are getting in the W plane, right? U equal to x square minus y square, and for x equal to b, we are getting u equal to b square minus y square. And for v equal to 2xy, for x equal to b, we get v equal to 2by. Again, we need to eliminate y from these two equations. So we get v square equal to minus 4b square into u minus b square. So again, this is the equation of the parabola, but here now the vertex is b square comma 0. Focus is at the origin. And also this is the equation of the parabola having u axis again in the negative direction, right? Because of this negative sign. So we are getting the parabola now as this. For x equal to b, this is the point b square comma 0, and this is your equation of the parabola v square equal to negative 4b square into u minus b square. Is that clear? Yes? Okay. So this equation represents the equation of the parabola with vertex b square 0, focus at the origin, and having u axis in the negative direction as the axis of parabola, right? Let's move on to the combined case. That is case 3, the combined case, right? Where we have taken the infinite strip a less than equal to x less than equal to b. So this is x equal to a, and this is x equal to b. This is your infinite strip. So this is your infinite strip, right? Let's get the image of this strip in the W plane. For x equal to a, we have got the parabola as this. For x equal to b, we have got the parabola as this, right? So the image is the region between these two parabola. This is the required image in the W plane. This is your first parabola, that is v square equal to negative 4a square into u minus a square, and that is your second parabola for x equal to b, that is v square equal to negative 4b square into u minus b square, right? So this is about when we have taken x equal to constant in the z plane. Let's take the case where y is equal to constant in the z plane. So now we are moving on to this case. So the case 4, where we have taken y equal to constant, let's say c, right, in the z plane, where x is belonging to the set of real numbers. As we are having u equal to x square minus y square and v is equal to 2xy, let's put the value of y equal to c over here. So we get u equal to x square minus c square, right, for y equal to c. And v is equal to 2xc, right? And here we need to eliminate x now, right? So eliminating x from these two equations, just put the value of x equal to v divided by 2c in this equation. Then you will get v square equal to 4c square into u plus c square. So what this equation represent now? This is again the equation of the parabola, right? With vertex, here we are having u plus c square. So the vertex becomes negative c square comma 0, right? And this equation of parabola is having u axis in the positive direction because we are having positive sign over here, right? So this time the parabola is in the positive direction of the u axis as the axis of parabola. So let's read this. This equation represents the equation of parabola with vertex negative c square 0, focus is at the origin, and having u axis in the positive direction as the axis of parabola. So let's draw this. So taking y equal to c, for this we are getting the parabola in the w plane as this. So this is your point, negative c square comma 0, and the equation of parabola is v square equal to 4c square into u plus c square. Similarly, for y equal to, let's say, d, this is your y equal to c, and taking y equal to d. So case 5 is, if I take y equal to d, for that we are getting the equation of parabola as v square equal to 4d square into u plus d square. Just replace c with d, and for that we are getting the, so for that we have got the equation of parabola in the w plane, and that parabola is something like this, and this is negative d square comma 0 the vertex, and this is parabola v square equal to 4d square into u plus d square. And now case 6 becomes the combined case of these two lines that are parallel to the x-axis, that is y equal to c and y equal to d. So we are getting the infinite strip that is parallel to the x-axis. For the sixth case, the infinite strip y greater than equal to c and less than equal to d. So this is y equal to c, and this is y equal to d, and this is your infinite strip that is parallel to the x-axis. For y equal to c, we have got the image in w plane as the parabola this, right? This is negative c square comma 0 the vertex, and for y equal to d, we are getting the parabola as this, the vertex negative d square comma 0. So this is v square equal to 4c square into u plus c square, and this is v square equal to 4d square into u plus d square, right? For this infinite strip, we are getting the region as between these two parabolas. This is the required region in the w plane, the image what we have got in the w plane, right? Now if I take the rectangular region, that is for xy, where x is greater than equal to a, less than equal to b, and y is greater than equal to c and less than equal to d, that is all the four cases, right? So where this region mapped? This region is in the z plane. So this region is mapped into the w plane. Where? Let's check that. So this is x equal to a. This is x equal to b. We have taken y equal to say this, and y equal to d this. So the common region is this, the rectangular region, right? The rectangular region, that is xy, such that x is greater than equal to a, less than equal to b, and y is greater than equal to c and less than equal to d. This is a region in the z plane. For x equal to a, we have got the parabola like this. For x equal to b, we have got the parabola like this. For y is equal to c, we have got the parabola like this. For y equal to d, we have got the parabola like this. That means we are getting the common region as this in the w plane, isn't it? I hope it's very clear to you. So this region that is in z plane is mapped into the region bounded by four parabolas, that is v square equal to negative 4a square into u minus a square, and v square equal to negative 4b square into u minus b square, and then v square is equal to 4c square into u plus c square, and v square equal to 4d square into u plus d square. So this is how we get the images in the w plane for the conditions in the z plane. So this is all about for the special case